Now let us look at the next problem. Consider the motion of a positive point charge in a region where two simultaneous uniform electric and magnetic field are acting. E equal to E naught J and B equal to B naught J. That means both of them, they are parallel and acting parallel to the y-axis. At time t equal to 0, this charge has velocity v in the xy plane, making an angle theta with the x-axis. Which of the following options are correct? Okay, now let us try to understand. Let us say this is x, this is y, and this is z. Now, and magnetic field, both E and B, they are parallel to the y-axis. Now, irrespective of the direction of motion of charge, okay, whether charge enters, it is given that it is always in the xy plane, and it enters with angle theta with the x-axis. Okay, so if this charge enters at any angle theta, it is always going to get accelerated in the direction of electric field, because electric field will exert a force F equal to Q into E. So it will have an acceleration in the y direction, which is equal to Q E by mass. Okay, now whether it will move initially with zero velocity along the y direction or not, it will depend upon the component of its velocity v in the y direction. Okay, sorry, this angle is theta. So velocity v has two components, one is vy and another is vx initially. Okay, now if it has a component vy along the y-axis, that means it is accelerated and it has got some initial velocity with respect to the y-axis. And if it has got some component in the x direction, that means the magnetic field which is acting in the y direction and the velocity component vx, it will make it move in circular fashion. Okay, now if you combine both the motions, that is in x along the xz plane and in the y direction, so it is some kind of a you can say a spiral with increasing pitch. Okay, now it is a spiral because this component vx, or you can say vxz, will make it move in the circular fashion, and because it has got some initial velocity vy and on top of it, it has got some acceleration ay also. So what will happen, that the pitch will keep on increasing in the y direction. Now everything depends upon the angle theta. Now let us look at the four options. Now if we say that theta is 0 degree, okay, it means that it is entering parallel to the x-axis. That means it is perpendicular to the magnetic field B. So it will have a circular path, but at the same time, because of its acceleration in y direction, it is not entirely circular. It will become spiraling up. It will spiral up with increasing pitch. Okay, pitch will keep on increasing. So option A is incorrect. Now let us look at option B. If theta is equal to 0 degree, the charge undergoes helical motion, which is that we had just discussed, with constant pitch along the y-axis. Now this is also not correct, because electric field will keep on increasing its pitch. If theta is equal to 10 degree, the charge undergoes helical motion with its pitch increasing with time along the y-axis. Now this statement is correct. And option D is, if theta is equal to 90 degree, which means that particle is entering parallel to the y-axis, which implies that it does not make any angle with the magnetic field, or it is parallel to the magnetic field. So there is no force acting due to the magnetic field. So it will keep on accelerating and the motion will be linear. So option C and option D both are correct.